So this class opener, everybody should be able to do. Number one, what is a solution to an equation? Anybody have an idea? What is a solution to an equation?
The answer.
The answer, yeah, but what makes it an answer? Okay, maybe we need to dig into this a little deeper. Like, let's say I told you x plus 2 equals 5. What's the answer to that equation? That's how to do it. Yeah, you subtract 2, but what's the answer? It's 3. So, ladies and gentlemen, the solution is 3. Now, why? Why is the solution 3? That's right. 3 is the number that when you plug in will give you a true statement. And that's exactly what I want to get at right here. What is a solution to an equation? It's the value or values that make it a true statement. Once again, what is a solution to an equation? What makes that answer the answer? That when you plug it in, it's a true statement. So it's the value or values that make it a true statement. Okay? So when you plug it in, is it true? If it's true, then it's a solution to the equation. Okay, let's move on to this next part. It says, name 3 solutions that work for this equation, x plus y equals 3. So it could, give me 2 and 1, you guys said, right? Yeah. Now, instead of saying x equals 2 and x equals 1, I'm just going to write it as a coordinate 2, 1, because a coordinate is an ordered pair, and that pretty much tells you that your first number is x, your second number is y, and that is true. 2 plus 1 equals 3. So this is a solution. Why is it a solution? Because when I plug it in, it gives me a true statement. Is there any other answers that work? They want 3 of them right here. 0 and 3, somebody said. Okay. Give me one more at least. 3, 0. Okay, switching it. And you know what? Somebody said -1 and what?
4.
And +4. Okay, so I wrote down 4 answers, but there's actually an infinite amount of answers, right? Like I could say 4, -1, or I could say 5 and -2, or I could say 6 and -3, or I could say 7 and -4, or I could say 8 and -5. You get the idea, huh?
Yes.
Or I could even say, I could say 100 and -97. I mean, how many answers are there? There's an infinite amount of answers. Even though right here, they only say name 3 of them. Okay, well, name 3 of them. We have 1 right here, 2 right here, 3 right there. Okay, now, let's move on to the next question. It says, question 2, when you graph an equation, what does the line really represent? Well, in order to answer this question, this equation right here, x plus y equals 3, we just said, yeah, here are 3 answers, but we know that there's an infinite amount of answers. I mean, you don't even have to go with regular whole numbers. You could actually say the coordinate 1.5 and 1.5, because 1.5 plus 1.5 is 3. So there's an infinite amount of answers. So how about this? Let me plot these 3 points, the ones that we circled in blue right there, 2, 1, 3, 0, and 0, 3. I want to plot it down here on this graph. Why? Because this equation, x plus y equals 3, they're asking us to graph it anyway, okay? Let me graph this one, this equation right here. I want to make it with the blue line, and it's going to be represented with these 3 coordinates, 2, 1, 3, 0, and 0, 3. So 2, 1, 2 on the x, 1 on the y is right there. 3, 0 is right there. 0, 3 is right there. What do you notice about these 3 dots? They all line up, correct? They all line up, all right? Now, what if I kept going with the other coordinates that are up here? The other ones are like -1, 4, 4, -1. So let's do that. -1 and 4. -1 on the x and 4 on the y. It still lines up. How about 4 and -1? 4 on the x, -1 on the y. It still lines up. So you guys get the idea? All of the infinite amount of solutions line up So this is the reason why we draw a line and put arrows on it, because this is the way to represent the infinite amount of answers that exist to an equation. Are you guys following me here? So let's go back and answer this question. When you graph an equation, what does that line really represent? So when we graph a line, that line represents the infinite amount of answers that exists to that equation. So even if we were to look at the above point over here, the 1.5, even if you were to look at that point, that's decimals. If you were to think about that, 1.5 on the x, it'd be right here, and then 1.5, where are you going to end up? Right on that blue dot anyway, right? Even if you were to think of the coordinate 100 and negative 97, you'd go out 100 way over here. I'm talking like way, it's too much, way over here, and then you'd go down to negative 97. Guess what? It's going to line up perfectly on that line. So why do we graph lines? Because they represent every single solution that exists to an equation. Are you with me? Okay, it's time to move on to the next section. The next section is 6.1, solving systems by graphing. So let's start with some vocab words. What the heck is a system? Well, when I think of a system in the real world, actually, somebody tell me off the top of your head, what do you think of when you think of a system? Any type of system. Digestive system, right? You eat something through your mouth, it goes down your esophagus, goes into your stomach, and afterwards. So there's a process and there's a lot of things working together. The PlayStation system, right? You have your console, you have your controllers, you need a TV. You can't just play without the TV. You need the outlet connection cord. There's a bunch of things working together. Circulatory system, your blood's running through all these different parts working through your body, right? Any type of system has more than one piece to it. So a system of equations is simply one or more equations working together. Okay, so maybe we need to pause right here, and maybe we need to go back and actually work through, or actually look at what a system is. Like, I'm gonna go back up here, and I'm gonna create this system right here. It's the equation x plus 2y equals 2 and x plus y equals 3, okay? And I want you to box it in. So go ahead and write it up there, box it in, and I want to ask you to solve this system. Now, what do I mean by solve the system? Since we're talking about two equations working together here, all right? Now, look at this. Right here on this equation, we have x plus y equals 3. Give me an answer that works for this one. X plus y equals 3. 2 plus 1, right? 2 plus 1. Now, if you're thinking that 2 and 1 are the answers, it doesn't work. Why not? Because even though 2 and 1 works for the bottom equation, this is a system, and both equations are working together. So you need to find the answer that works for both. And if you try to plug in 2 right here and 1 right here, it's going to say 2 plus 2, and that's not 2. Does that make sense? So 2 and 1 did not work. Could anybody start, I mean, there's a lot of us here in this class. Let's start guessing and checking, and let's see what correct answer would work for x and for y for both top equation and bottom equation. Because it has to work for the whole system. Anybody? What could I plug in into my x's and y's that'll give me 3, and into my x and y up here, the same values that'll give me an answer of 2? 2 and 0? Okay, so if I go 2 plus 0, it'll give me 3. Wait, it won't give me 3. 2 plus 0 is 2. That's a 3. Oh, the bottom equation. I mean, I'm saying, yeah, 2 and 0 works for the top one, but 2 and 0 does not work for the bottom one. Anybody else? So 2 and 0 didn't work. 2 and 0 didn't work. 2 and 1 didn't work. So this guy didn't work either. Any other guesses? Come on, guys. There's like 20-something of us here. 27 brains. We could be able to figure this out. I heard negative numbers. You're on the right track. Anybody?
-4.
-4, and you need 2 numbers, x and y.
Wait, for which one? The bottom one or the top one?
Because it's a system, it has to work for both.
What do you think?
-4 and -1. Let's think about this. negative 4 plus negative 1, it's going to be negative 5, not positive 3. Okay, so you're saying negative 4 and positive 1? Well, if I go negative 4 plus 1, I'll get negative 3, not positive 3. So that didn't work either. Any other ideas? We're almost there. I know we could get it. Come on, guys.
Yeah, positive 4 and negative 1?
Positive 4 and negative 1 is correct. Right? Check it out. Check it out. If I plug it into the top one, it's going to say 4 plus 2 times 1 equals 2. I'm sorry, negative 1 equals 2, which means that you have 4 minus 2, and that really does equal 2, doesn't it? So it does work for the top one. How about for the bottom one? 4 plus negative 1, 4 plus negative 1, does it give me 3? Yes, it does. So I've double checked it. So my correct answer to this system is 4 comma negative 1. That's your answer, right? Do we understand it? You understand how to do this method? Okay, now we're not going to use this method. What? Okay, why not? Because you could be all day guessing, right? And it could get really disgusting, right? The easier way is to say, you know what? I know that if I were to graph this guy, it's going to give me a line, and that line represents all the answers. And if I graph this guy, it's going to give me another line, and that line represents all the answers of this equation. So if I have both lines, and I want to find the point that's in common, if I want to find the answer that works for both, what I'm really looking for is a point of intersection. So check this out. If I take that top equation, if I take that top equation and rewrite it in slope-intercept form, if I subtract x and subtract x, I want to have a 2y equals negative x plus 2. And then if I divide everything by 2, divide by 2, divide by 2, there's an invisible 1 up here, divide by 2, I'm going to get the equation y equals negative half x plus 2. Are you guys with me? That's for the top equation. Let me circle it in red because I wrote it over here in slope-intercept form in red. And the other equation, this bottom one, I want to do it in blue. And guess what? I already graphed it. Look over here, guys. It's that same equation, x plus y equals 3. So that blue line is already there. Of course, if I wanted to, I could subtract x on both of them and have y equals a negative x plus 3. Then you would know, oh, it crosses at 3 right here, and it goes down 1 over 1, down 1 over 1, down 1 over 1. There's my blue line. Let me graph the red line. The red line crosses at 2, so it crosses right here. And what do I do from that point? What's my slope? Come on, guys. What do I do from the b value of 2? What's my slope? Negative 1 over 2. So you're going down 1 over 2. And if you do go down 1 over 2, you end up right here. And if you kept going down 1 over 2, you get over here. And you could even use the pattern backwards and go like over 2 this way, up 1. Then over 2 this way, up 1, to make the line as long as you want. But my point is this. When I graph an equation, the red line represents that top equation, which we did in red, and this line represents all the answers that exist to that top equation. When I graph the bottom equation, this blue line represents all the answers that exist to the bottom equation. So on a system of equations, you want to find the answer that works for both. So if you have all the answers of one, all the answers of the other, where is it that you're going to find all your answers of both? That point of intersection right there. And that point of intersection right there, the coordinate is 2, 1. 2, 1. Which means that your answer, your x value is 2, your y value is 1. And that's why the solution to the system is 2, 1. Does that make sense? So the answer to this system is 2, x equals 2, y equals 1. And if you were to plug it in, you would double check it. And that's a lot better than guessing and checking.